In this video, we're going to talk about how to graph polynomial functions. We're going to talk about how to determine x and y intercept, how to find local maxima and minima using the first derivative, and how to find inflection point using the second derivative. So the first one, we determine the x intercept. Use the y equals to 0. Let's say we got the fx equals to 6x squared times x minus 3. So the first thing we have to do is we let the fx equals 0. So we just write it down, 6x squared times x minus 3 equals to 0. When it comes to this equation, we need to separate to first one is x minus 3 equals to 0. Then we will get x equals to 3, 0. And then the second one, 6x squared equals to 0. We can't just ignore this 0, so it will be x equals to 0 over 6. And for sure it will be 0. So the point is 0, 0. So the second one, we need to determine the y-intercept. Use the x equals to 0. So the function equation is fx. We just substitute the 0 into the function. And we get 0. So the point for y-intercept will be 0, 0. The third one is to finding the local maxima and minima. First thing we need to do is differentiate the function equation. Function equation is 6x squared x minus 3, or it can be becomes 6x cubed minus 18x squared. Now we differentiate it, write it down as f prime x 18 minus 36x, and then we equalize it with 0. Now we need to factorize it, bring the x to the outside. X minus 36 equals to 0. Bring 36 to the other side. Then 36 divided by 18, we will get 2. So the x value is 2. And the second one, x is equals to 0. So to find the y value, we need to substitute the x value into the function equation. And x is 0. Of course, it is 0. The critical point is 0, 0. When x is 2, negative 24. So this is the y value, and then the critical point will be 2 and negative 24. So the local maxima will be 0, 0. The minima is 2 with a negative 24. Simply just look at the value of y. Negative 24 is less than 0, so 0 is above negative 24. That is why this is the maxima and this is minima. The last but not least, we need to find the inflection point. To find the inflection point, we need to use the second derivative. F double prime equals to 36x minus 36. Just like the previous one, we need to equalize it with 0. So just simply bring the 36 to the right side. Then we get x is 1. This is the x value. Now we need to find the y value. And x is 1. Substitute 1 into the function equation. Sorry. Negative 12. And the inflection point will be negative 12. And now you'll be able to sketch the graph. Since the equation that we have is an odd degree, then the end behavior will go opposite direction. It can either go down and then up for the positive leading coefficient, or go up and then down for the negative leading coefficient. So the function equation that we have here is positive with the odd degree, and it will be like this square. So now I'm going to show you the simple of sketching graph. Point 0, 0 here. Fx against x, negative 10 here, and the negative 20. Next we need to plot the point that we have here, 3, 0 for the y-intercept, 1, negative 12 approximately here, 2, negative 24 around here. Since this is a positive and an odd degree equation, the graph will come from the bottom, which is negative infinity, and then it goes up to infinity. So let's sketch the graph. So as you done sketch the graph, don't forget to show the coordinate at the point. This is a 2, negative 24, 1, negative 12, 3, 0, and that's it. Alright guys, that's all for me. Thank you for watching, and remember, stay safe.